Hello everyone, I am Dr. Godanda Raman. In this section we are going to discuss with short question and answer unit 1 linear programming problem. See, the question is, what is the optimality condition for the simplex method? In the simplex method, an optimal solution is reached when all the entries in the objective function row are non-negative for maximization problem or non-positive for minimization problem. So for maximization, the optimal when it's reached if all Cj minus Zj when is less than or equal to 0, then it's reached. In minimization, optimal if all Cj minus Zj when is greater than or equal to 0, and then it's optimality reached. Define optimal solution. An optimal solution to a linear programming problem LPP is a solution that maximize or minimize the objective function while satisfying all the constraints. Define unbounded solution. A solution is unbounded if the objective function can increase in maximization or decrease in minimization indefinitely without violating any constraint. It occurs when there is no limiting constraint in the direction of improvement. So this is an unbounded solution. Define feasible solution. A feasible solution is a set of value for the decision variable that satisfy all the constraints including non-negative of the linear programming problem. Define surplus variable. A surplus variable is introduced to convert greater than or equal to constraint into equation by subtracting the surplus from the left hand side. So surplus variable when is greater than or equal to constraint to convert into equation form. So minus S1 we are adding, minus S1 equation wise we are adding minus S1 minus S2 minus S3 and so on. Artificial variable. Artificial variable or temporary variable introduced into constraint usually greater than or equal to obtain an initial basic solution for the simplex method. So they are used during the BigGum method or two-phase method. Is greater than or equal to type of problem, equal to type of problem, artificial variable. Some books they are using R1, R2, R3. Some books they are using A1, A2, A3 and so on. Slack variable. A slack variable is added to a less than or equal to constraint to convert into an equation. So when is less than or equal to, we are changing. And form the dual of the primal. So see the problem, minimize is at equal to 20x1 plus 40x2 subject to the constraint 2x1 plus 20x2 greater than or equal to 40, 20x1 plus 3x2 greater than or equal to 20, 4x1 plus 15x2 greater than or equal to 30, x1 and x2 greater than or equal to 0. So now to consider, to convert this is a dual, convert dual primal into the dual. So now first of all minimize. So minimize to condition to change into the dual problem maximize. This notation we can use any one. So y or z or w. So z already used. So we can change w or capital Y. Now how to convert this? So minimization changed into maximization and see this right hand side. Okay. This right hand side to convert to consider this is a right hand side. We are going to take objective function where here the right hand side value to change into the objective function. So this value to move on to the right hand side. So 40 y1, 20 y2, 30 y3, this right hand side. Then the objective function 20, 40 is moving to the right hand side. Now next the greater than or equal to value, when the greater than or equal to is changed into the less than or equal to. So this greater than change into less than or equal to, and then this values, which value? So this row, the values. Now to consider y1, so this whole term to consider y1, so 220. Therefore how to change this? This is a y1 and this is a y2. Therefore 2 y1 and then 20, so sorry, this is a y1, y2, y3. So therefore y1 to consider 2 y1, 20 y2, 4 y3 is the first equation. Then less than or equal to, the constraint change less than or equal to, then this values moving to the right hand side. So therefore how to change this? Minimize change to maximize, and then the right hand side value, what is the right hand side changes? See, this right hand side only we are taking the objective function. So therefore for here 40 y1, 20 y2, 30 y3, and subject to the constraint. So subject to the constraint, what is the constraint here? So first equation, for this y1, y2, y3, therefore this is a we consider. So 2y1 plus 20y2 plus 4y3. Then next one 20y1 plus 3y2 plus 15y3. Then this all greater than or equal to change into less than or equal to, and then the objective function value in the into the right hand side. So 20, 40. Now y1, y2, y3 greater than or equal to 0. So this is the changes primal to dual. So similar problem, see here, form the dual of the following primal problem. Maximize z 4x1, 10x2 plus 25x3. Subject to the constraint is given. Now change into the dual problem. This maximize change into minimize, and this right hand side value to change into the objective function. So 25, 30, 40, and then the objective function value take in the right hand side. So 4, 10, 25. So the less than or equal to change into greater than or equal to. Now to consider y1, y2, y3, for this first value 2y1, 4y2, 6y3, then 4y1, 9y2, 8y3, and then 8y1, 8y2, 2y3. So this is our dual problem. And then next problem, see, form the dual of the primal. Minimize change to maximize, and then right hand side 100. So y1, y2, y3. Therefore the objective function 100 y1, 20 y2, 120 y3, and this is a change to right hand side 5, 8. Now this is a y1, y2, y3, y1, y2, y3, and this is a objective function. So 4y1, 2y2, 2y3 greater than or equal to change into less than or equal to, and 9y1, y2, and 5y3 less than or equal to 8. So this is our primal problem convert into dual problem. Thank you.